Okay, in this video we are going to take a look at transforming our new parent function, the reciprocal function. So we'll have a little bit of reminder of how our transformations go. I have put a copy of our parent function information for the reciprocal function there for us to reference in case you don't have yours with you. All right, so as we always do when we're starting with the transformation, we create an arrow for the parent function. In this case, it is the reciprocal function. The arrow looks like that. And then we can come up to our list of transformations that we want to perform and identify them as vertical or horizontal. Down 6, that is definitely a vertical transformation, but reflecting over the y-axis is a horizontal transformation. Stretching horizontally by 2 obviously is a horizontal transformation, and shifting right 3 is also a horizontal transformation. So tacking on here, we are going to get 3 horizontal transformation arrows, and we are going to get 1 vertical transformation arrow. We can fill that 1 in. That's shifting down 6, so that's a subtraction of 6. Reflecting over the y-axis, reflections are sign changes. Stretching is multiplication by 2, and shifting right 3 would be adding 3. So if we now want to build the function, we start with the x over here. Opposite there is not adding 3, it is subtracting 3. Opposite of that, or the inverse of multiplying by 2 is dividing by 2. The inverse of a sign change is a sign change. We flip over and subtract 6. So that is our complete set of arrows. We can start then to build the function by putting an x at the beginning. We take the x, subtract 3, divide all of that by 2, change the sign on the whole thing, and then it goes into the reciprocal function. We also will refer to the reciprocal function as the flipping over function. So what that actually does is it flips that fraction over, makes it a 2, negative 2 over x minus 3, and then we subtract 6 from that. So that is our final function. The g of x that we're looking for is negative 2 over x minus 3 minus 6. All right, so I'm going to not do that. I'm going to shrink some of this information down so we can sketch a graph. I'll stick it up here so we have that there. So if we want to sketch a graph, then we're going to grab this information from up here. So our key points that go under the parent function are a negative infinity describing the left end of the function with an end behavior of 0. Negative 1 is on the graph. When we try to put a 0 in, we get a vertical asymptote, as the notes say. An input of 1 gives an output of 1, and we catch the other end is also heading to an end behavior of 0. And we follow the arrows, subtract 6. Negative 1 minus 6 is negative 7. A vertical line moved up or down 6 places is still a vertical line. 1 minus 6 is negative 5, and 0 minus 6 is negative 6. On this side, we do a sign change, so that will become infinity 1, 0, negative 1, and negative infinity. So we've flipped that axis around. 2 times infinity is still infinity. 2 times 1 is 2. 2 times 0 is still 0. Negative 2, and still a negative infinity there. and negative infinity plus 3 is still, or infinity plus 3 is still infinity. 2 plus 3 is 5, 0 plus 3 is 3, negative 2 plus 3 is 1, and negative infinity plus 3 is still negative infinity. So we have some information from these points as inputs to those numbers as outputs that we should be able to use to sketch a graph. So we'll grab a little bit more space here. Get an axis to grab this stuff on, okay, or to graph this stuff on. Our output values have to be down here a little ways. So 1, 2, 3, 4, 5, 6, 7 should take care of it. Our inputs, 1, 2, 3, 4, 5 should take care of it on our inputs for us. And so let's plot the points that are, well, let's actually throw in our horizontal asymptote here, which we identify in our end behavior as -6. So if we come down to -6, we're just going to dash a horizontal line across there because that describes what this function is doing at its ends. Our vertical asymptote here, vertical asymptote is at 3, so we'll come over to 3 and sketch in where that vertical asymptote is going to be. And then we can plot our other points. We've got a point at 5, -7. That is about there. We've got a point at 1, -5. So over 1, down 5. And now we draw the graph with the shape that we know that it's supposed to have. It identifies that it must be coming from here through that point and up this direction, and from down here we'll come up and through that point and off that direction, and that should roughly be what this graph looks like. We see the kind of this centered area in here at to the right 3 and down 6, which represents our new location through the transformations there. And that's how we sketch the graph and transform the reciprocal function. Most of that should have felt like review.